right, my fellow scientists, before you watch this video, if you haven't already, make sure you go to your textbook and read page 126 to 129 about forces and invisible forces. Once you've done that, then you can come back and watch the video. If you already have, you're ready to go. So we're gonna get started. We're gonna talk just a little bit about force. If you want an object to move, whether your object is a wiffle ball, a basketball, a car, or an elephant, you need some type of force to move it. And we learned in these first couple of pages that a force can be something that pushes on the object, or it can be something that pulls on the object. Sometimes you can see it. Right now, you can see my hand on the ball, and if I push it, you can see me push it. And if I pull it back to myself, you can see me pull it. Sometimes you can see it. Other times you can't, and we'll talk about those forces in a minute. But a force on an object is going to cause it to do something. You can create a force on an object that's not moving. For example, right now, my basketball is not moving. I can put a force on it, and I can push it and cause it to move. I also might have an object that's already going. It might already be in motion. We read about this. So if an object is already in motion, I can add a force and cause it to change direction or change its speed. There were a couple other things in our chapter that we want to make sure we pay attention to. My object is always going to move in the direction of the force. So if I push the ball away, it's going to move the direction that I pushed it. If I pull it back to me, it's going to move the direction that my force went. That's really important for us to remember. The next thing that we want to go over quickly together is that an object, while it has a force that sometimes you can see, sometimes it might not. So in your page, in your textbook, on page 128, you can look at that right now if you want, or you can just listen along. There are a few forces that you don't see that act on an object. The first one that we talked about in your book on page 128 is friction. Friction is what is going to slow something down or cause something to come to a stop. So when you think about friction, I want you to think about surfaces. Some of them, like this one, is very smooth. So we have less friction, which is why if I roll this ball, it would go pretty quickly off the top. Now think if I had filled this with dirt or sand and I tried to roll this ball through, would it go as far? Probably not, and we'll play around with that a little bit in our lesson tomorrow. It probably wouldn't go as far or as fast because the force of friction is acting on the object to stop it, which you read about in your book. The next thing that we heard about for our invisible forces was gravity. And we all know about gravity. We experience it every day. Gravity is a force that pulls objects downward. So it's pulling things down. So if you have an object that's flying through the air or being pushed or pulled when it goes from the air down to the ground, my hand was not actually the force. Me letting go caused gravity to go to work and pull the object down. So that force of gravity is a pull. The other thing you learned about in these couple of pages is weight. The concept of weight versus density versus mass can get a little bit confusing, so make sure you're going slow enough that you can pay attention to the definitions. But weight is basically what we're doing is we're measuring how much gravity is working on an object, and we use scales to do that. We'll get into that a little bit more later, but what you need to remember mostly is that weight is a measure of gravity. And then the last one that you had for invisible forces is magnetism. We'll have a chance to play with magnets as well, but we know that magnets can also push or pull on an object. We've used magnets on our board. You probably have some at home on your fridge, or even the paper clips that we have in the classroom, or those little magnets in our toys. And we know that sometimes you have to flip the magnet around because sometimes it will push and sometimes it will pull. So what I want you to do today is just take the things that you've learned in the book and make sure that we get those ideas really well in our minds. So you're gonna go to page 102 in your workbook, which is the back of the side that you did yesterday. And there's just a few questions that I want you to answer. I would like for you to do 1 through 7. And so these are, all they are is fill in the blanks. And so you might need to go back to your book. If you have to go back to your book, that's okay. Remember, you can always look at the very bottom of the page and it's gonna tell you exactly what page numbers to look through for your answer. So I just wanna read through these quickly so that you have a better idea of what the questions wanna know. The first one says, a wagon cannot move unless a blank causes it to move. You don't need to think necessarily about a wagon, just think about an object. What's that word that we started with in this chapter that needs to happen to an object to cause it to move? All right, the next one. A force is needed to make an object go blank, blank, or change blank. So think about an object maybe that's already in motion or stopped. What are the 3 different things that a force will do to that object? The ball goes in the blank direction as the force. So we talked about this before. If a force acts on an object, is that object going to go with it in the same direction, or is it going to go somewhere else? Magnetism is the blank or blank force caused by a magnet. So if you're having trouble with this one, go look for the bold word of magnetism in your book. What force slows or stops motion? You can give me one word. You don't need to give me a complete sentence. What force pulls objects toward the center of the earth? So go back and look for that one. And then what is weight? For what is weight, they give you quite a few lines here and a good bit of space. I really, really would like to see from you a complete sentence on this one. Remember, for a complete sentence, and you only have to do it for one, I'm looking for your penmanship, your capital letter, punctuation, and for spelling. The words that I care to be spelled correctly are words that were in this chapter or on this page. If it's not in here and it's something else that you're pulling from your brain, I don't want you to worry too much about the spelling. But those are the 3 things, as usual, that I'm looking for on that question. And then the last thing that you have, excuse me for one second, I'm going to just push this up into the screen where you can see it, is we have a picture here. What I would like for you to do, and you have 2 options for this. You can do it right here on this section of the paper. It doesn't need to be perfect, doesn't need to be complete sentences, or you can do it on a separate sheet of paper. What I want you to do is I want you to take a look at this picture and list for me the forces that you think are acting on this picture. So think about what might be happening with the poles, with the skis, with the snow underneath. Think about what might be causing him to go faster, what might be causing him to go slower, and you can just list those here. So you might tell me that, for example, the poles, are the poles causing a push or a pull? Is there friction happening anywhere? So you can just give me a word and you can give me the force that's happening in that picture. Once you do that for today, that's all I would like for you to do today. And tomorrow, we're going to learn and play around a little bit more with friction. And if you have any questions, I'm right in the words there. If you have any questions, remember, you can email them to me. Mom or Dad can send them to me on my Remind, and then same with your workbook page. You can take a picture of it and send it to me, or you can just keep it in your folder and bring it back on Monday the 29th, 1st, whenever we come back. You can bring it then.